Okay, well, let's take a look at this sequence here. Okay, we start with 10,000. Looks like our next term is 1,000, our next term is 100, and our next term is 10. Okay, so let's think for a minute. It's very obvious right away, right, that we're not changing by the same amount each time, right? This is definitely not a linear relationship. So could it be a geometric relationship? You might be a little tripped up at first because you're saying, well, wait a minute, this is or rather the terms are decreasing each time, right? And they seem to be decreasing pretty quickly. You might think, well, geometric sequences grow really fast, right? So shouldn't a geometric sequence be growing? Well, let's remember back to some of the stuff we learned with linear relationships and linear sequences, right? The last couple lessons, we investigated a number of examples where a linear relationship or a linear sequence or a linear function was decreasing, right? Like water being leaked from a pool, gas leaking from a gas container or a gas tank, someone selling their video games or selling anything that they have a lot of, right? So we know that a linear relationship can decrease if the common difference was a negative number, right? Very similarly, a geometric relationship can decrease if the ratio is less than 1, right? In this case, the common ratio, the common ratio for this sequence here is 1 over 10, right? It's 1 over 10. Let me draw that 10 in the denominator a little better than that. This is a common ratio 1 over 10, right? Multiplying by 1 over 10 is the same as dividing by 10, right? So if we start with 10,000, divide by 10, which is the same as multiplying by 1 over 10, we get 1,000, right? Divide by 10 or multiply by 1 over 10 again, we get 100, right? Do it again, we get 10, right? Well, can we figure out what the fifth term is, right? If the fourth term is 10, right? Our fifth term, right, should be 10 times our common ratio, right? 10 times 1 over 10, that's 10 divided by 10, right? That's 1. So our fifth term is 1, right? Can we find our sixth term? Can we find our sixth term? We should be able to, right? We take our fifth term, multiply by the common ratio, 1 over 10, and we get 1 over 10, right? Or 1/10, right? And get the seventh term, let's just do that real quick. To get the seventh term, right, we would take our sixth term, 1 over 10, and multiply by the common ratio, 1 over 10, right? Well, we know how to multiply fractions. 1 times 1 is 1, 10 times 10 is 100, right? So our seventh term would be 1 over 100, right? So geometric sequences can definitely decrease also if your common ratio is less than 1, right? Because if you're multiplying by a number less than 1, you are decreasing the value of the number you started with. All right, so let's look at this sequence. Well, clearly we started with positive 60, right? Then we got positive 20, so automatically we can tell that this is a decreasing geometric sequence, right? So automatically we should know that our common ratio is going to definitely be what? It's definitely going to be less than positive 1, right? So we should be able to tell this right off the bat. So let's look at our third term. It's 20 over 3, clearly less than 20, right? Our fourth term is 20 over 9, clearly less again because the larger your denominator is, if you have the same numerator, the smaller the value of your term is, right? So can we figure out what the common ratio is in this case? It might not be totally easy to tell right away. You might be able to, but it might not be very super obvious to you what the common ratio is. But remember that we can find out, right? How can we find out? We can find out by taking any given term, right? Taking any given term, like 20, and dividing it by the immediately previous term, right? like taking the second term and dividing it by the first term, taking the fifth term, dividing it by the fourth term, taking the 27th term, dividing it by the 26th term, right? That will always give you the common ratio if you have a geometric sequence. And what is 20 divided by 6? Well, that's the same as 2 times 10, right, divided by 6 times 10, right? I'm going to do this a step at a time. The 10s cancel out, so this is the same as 2 divided by 6, right? Well, 2 is 2 times 1. 6 is 2 times 3, right? Cancel out the factors of 2. We get 1/3. So it looks like our common ratio is 1/3, right? And it should also make sense if you look back at our sequence. What would you do to get from 20 to 20 over 3? Clearly you divide by 3, right? Which is the exact same thing as multiplying by 1/3. Let's check one more pair of terms. Let's take the fourth term and divide it by the third term just to be sure, okay? Let me create some space so we have some room to calculate that. Create some space so we have some room to calculate that. I still want to keep that notification that our common ratio has to be less than 1. It's a good thing to keep in mind. Okay, there we go. Let me get my brush back. Let me get my green back. Okay, we want to take the fourth term, 20 over 9, divide it by our third term, 20 over 3, right? Here's how we have to remember, well, here's when we have to remember how to divide by fractions, right? What you do is you keep the fraction that's in the numerator of the larger fraction, right? You keep your first fraction. Then you take the fraction you're dividing by, or the fraction in the denominator of the division, and you take its reciprocal, right? Which means you flip it upside down, right? So that becomes 3 over 20. So 20 over 9 divided by 20 over 3 is the same as 20 over 9 times 3 over 20, right? Okay, let's see. Automatically, we can notice that these factors of 20 are going to cancel out, right? That's going to be 3 over 9, right? Well, we should recognize that 9 is going to have a factor of 3, right? In fact, it's 3 times 3. So this becomes 3 times 1 divided by 3 times 3. One factor of 3 will cancel out. And once again, we'll get our common ratio of positive 1/3. And then, for example, what if we wanted to find the fifth? What if we wanted to find the fifth term in this sequence, right? What would we do? We'd just take our fourth term, wouldn't we? We'd take our fourth term. We'd take our fourth term. Let me just make some room here. We'd take our fourth term, 20 over 9, right? Multiply it by the common ratio, 1 over 3, and we'd get 20 times 1 is 20, divided by 9 times 3 is 27, right? So our fifth term would be 20 over 27. And of course, we keep going with this process infinitely, right? The only thing you need to do to find the next term in the sequence is multiply the last term by the common ratio, which is positive 1/3.